Welcome back to the hyperbolic suffering chamber or the hyperbolic bowling chamber. We are back once again. You may have noticed that it is easy to see that the sands of time were conspiring against us and everyone in the hyperbolic coding chamber Discord. So I along with everyone else in the hyperbolic coding chamber Discord, along with some top tech executives and powers in the world, decided to put a contract together, and we were able to secure one more hour of sleep for everyone across the globe. So if you benefited from that, you're going to want to join the hyperbolic coding chamber Discord, because it was a great effort to make sure that you got some extra sleep last night. That being said, there'll be many more threats to conspire against the hyperbolic coding chamber's success ratio. So we have to stay. This sounds very militant, but yeah, we are back once again. We have some comments. More to do, more to think. So we have some comments. I'm realizing my thing isn't uploading, or maybe it's not updating. But yeah, yesterday's session was pretty long. It actually ended up being kind of pogged. So I think I am maybe ready to run again. And it could be maybe that the challenge of 30 to 45 minutes a day was too, I think it's fine to keep going, but maybe to get excited, I had to find another way to spice it up. I think I'm down for 1 hour and 30 minutes again. It's interesting because I don't know if it's because I don't have the ability to focus, but it turns out that now recently, yesterday we did 1 hour and 30 minutes. I realized in the last 10 minutes or so, last 10 to 15 minutes, I just ran out of brain sauce. There was just nothing left in the tank. So I just couldn't think. But earlier in the year when we did 1 hour and 30 minutes, I reached that limit much faster. It was like the last 35 minutes or so, I was just pretty much barely thinking. So that's progress. So yeah, it's interesting how long things take, or how long it takes the brain. But interesting nonetheless. But we have some comments here. We have from Ziggy Mankini. This series has inspired me to take a proactive approach and try something similar. Feels strong, man. You have figured it out, sensei. Yeah, I was also watching the anime Blue Lock. And yeah, no spoilers, but pretty much they're a soccer team. They're creating soccer from zero. And everyone on the team had a weapon. And it made me think about it. I was thinking about problem solving. I was trying to think, what is my weapon? If everyone, if the court was LeetCode, and the team or the field was LeetCode, and my team was the Discord. Okay, this is getting too meta. But I was trying to figure out what my power would be, or my weapon would be, in terms of problem solving. I feel like maybe everyone has a certain way of thinking about things that gives them like a buff in a certain scenario. But I was trying to figure out what mine's would be. So I figured if I was given a task or a problem, what would be the ideal problem to make the most use of the way that I think about things? And I'm not exactly certain what that is. I'm not exactly certain what that is. But in the anime, they're encouraged to polish, and real life is an anime. This is Blue Lock, except the Coliseum or wherever they're actually playing soccer is real life. So maybe there's something to figuring out what our weapons are. But the more I do LeetCode, the more I'm figuring out some cheat codes about just the way I work. So maybe there's something there. We have a comment from Zeta Mu Sigma. Pretty cool name, by the way. Also, Sigma from Mega Man is an epic character. Feel strong, man. Good going, my guy. You too, brother. We have Crisis, legendary human being. Legendary human being. Will do. Legendary human being. Good stuff. Hidden gem of a channel. Hey, feel strong, man. Feel strong. Rad, dude. Grad, dude. And then we have finally, how many have you solved? Actually, have not solved that many problems. I think if we check the LeetCode leaderboards, I think I've only solved about 190. Majority of those being easy problems. I kind of would like to change to mediums, but I don't know if it's worth it. For some reason, I think it's fun to kind of play the game of LeetCode like I feel like it's kind of fun to play the game of LeetCode like a video game. Like I'm just trying to beat all the levels. So I don't really feel I don't know. I just don't feel like a rush to complete it as fast as possible, or try and like rush through, or do problems in specific orders or anything like that. It's more of just how long can I keep doing this? And yeah, I think that would be pretty cool. But yeah, so we have, I think that might have been everything. Do have, oh yeah, so I was also going to do I was suggested to do a problem from Lil Mustard himself, legendary programmer, called ones and zeros. So we're going to do that today. And then what else are we going to do? We're going to do ones and zeros. There's a problem I left off on yesterday. Actually, we're probably just going to do ones and zeros. And if we can solve that problem, it has a lot of dislikes, which is not a good sign. But if we can solve that problem, I'll switch to the weekly suffering contest. I got a little bit fed up with the weekly contest just because I think the company who sponsors the weekly contest kind of paints a certain vibe on the questions, and they're just very math based like the last 3 weeks, and I was just like, ugh. But we should probably do them anyway. I learned some stuff about greatest common factors. Actually, we didn't. We never look at the solution. But yeah, more to be done. But for some reason, the length of 1 hour and 30 minutes is energizing me, so that is also the wave. I was also doing some more thinking. When I was doing this session earlier in the morning, it was actually easier to get it done early in the day. That way, it wouldn't pretty much lay on my conscience for the rest of the day to get done. The big problem with that was that I'm thinking that there's like a startup time or a lag time to brain, because even if I did it after work, I felt like this is the analogy. Solving the LeetCode problem is like for looking through the maze. You have a maze, you're looking through, you're trying to search through the maze to find a path to get out. Once you get out, you solve the problem. But if I did the problem earlier in the day, right? Let's just say there's a lot of shrubbery. There's a lot of grass, shrubbery, trees, rocks, just general things in the maze that are like, they don't change the path of the maze, but it's just kind of wasting time. Maybe I might trip on a rock. Maybe there's a lot of vines to move out of the way. Whereas later on in the day, I have a lot less juice, but there's a lot less shrubbery. So it's like clearer to think. So yeah, I wonder that's probably because of the brain and sleep and all that stuff. Because I remember I used to do it right when I wake up, which I think is too soon. Because I'm probably more creative and less able to focus. Because I know there were a lot of people in history who tried to be more creative by like abusing the sleep cycle. Because I think it's when you're close to sleep, if you're low on sleep, and after you just wake up, you're more creative. I think there's a story of Einstein. He would pretty much sleep in a chair with a cup full of water, sitting in a chair, and then the goal was to be more creative. So even back then, people already knew like there was something there with sleep and creativity. But yeah, I think even he knew, or I think he wrote that he noticed that he was less creative when he had more sleep. So the better rested he was actually less creative, which is tangentially true. So anyways, he would sleep in the chair with the cup, or was it a spoon? Either way. And then the beauty was that when he was close to falling asleep, he would drop the cup and it would pour water on him and he would wake up. And then from there, as soon as he would wake up from his slow drift into sleep, he would burst into work to try and use the creativity. All this to say, I'm waking up and doing LeetCode right away. Even after rowing helps. After rowing helps a lot, but it's kind of variable because if the workout isn't hardcore enough, then it doesn't start my brain. But yeah, ideally we would have no work and I could do it midday when I am sharpest, but it doesn't feel that way. Ironically, also other times we've been able to fry when I thought it was going to be some of our worst sessions. So maybe it's just time to accept it. And I think I'm just going to jump. Something we don't have to accept is not joining the hyperbolic coding chamber. So you're going to want to join the hyperbolic coding chamber because it's a pretty epic chamber. And yeah, so I'm just going to jump into the LeetCode. And we have ones and zeros to start, and then we'll do the weekly suffering. And then, yeah, I'm just going to start the timer. So let us begin. You are given an array of binary strings strs. So I'm given an array of binary strings. Have I done this problem yet? Okay, I haven't. You are given an array of binary strings str. So an array of binary strings, looks like an array probably have a bunch of zeros and ones. And two integers m and n. So integer array m and n. Okay. Well, no, an array of binary strings, and then we have two integers m and n. Return the size of the largest. Return the size of the largest subset of strs, such that there are at most m zeros and n ones in the subset. Turn the size of the largest subset of strs such that there are at most m zeros and n ones in the subset. Return the size of the largest subset of strs. Return the size of the largest subset of strs. Return the size of the largest subset. Now, what is a subset? Maybe it means each individual element. Subset of strs such that there are at most m zeros and n ones. So m and n are just the requirement for the max number of max number of zeros and ones. At most, meaning maybe we don't need to use all of them. A set X is a subset of a set Y if all elements of X are also elements of Y. So, example 1, we have strs, our array of binary strings. Looks like they're arbitrary length for each one. And we're saying we can have m zeros, at max m zeros, and at max n ones. Okay. The largest subset with that, 5. Let me make this a little bit wider. The largest subset with at most 5 zeros and 3 ones. The largest subset with at most 5 zeros Wait, did I change my thing? Okay, I did. The largest subset with at most 5 zeros and 3 ones. One zero. Subset is really, the largest subset. There are 5 total elements, which means the last element we didn't use was 1 0 0 0 0 1, and this one in the center, which means that they did say largest subset, which means we don't really care about the order. Okay, so the answer is 4. Other valid but smaller subsets include 0 0 0 1 and 1 0 and 1 0. Other valid but smaller subsets include is an invalid subset because it contains 4 ones greater than the maximum 111001 is an invalid subset because it contains 4 ones. Right, and we're only allowed 3 ones. Yeah, I'm going to change the parameters from M is now going, actually no, maybe it's better to get used to, I was just going to change M to 0 and N to Z. 1 and 0. I think there's a couple different ways you could do this. Maybe this is a dynamic or knapsack problem. I'm balls at dynamic programming problems. Okay, so now we have an array of binary strings 1, 0, 0, and 1. We want to at most 1, 0, and at most 1, N. And the largest subset we can do with that is 0 and 1. Okay, this next example definitely changes the approach I was going to do. Excuse me for the gas. Stirs out length is up to 600, and stirs sub I dot length is less than or equal to 100. So they're saying the binary string length is, yeah. String sub I consists of only digits 0 and 1. M and N are at least 1 and go up to 100. I see. At most. I guess we can think of some approaches. One approach I'm thinking of, maybe we could treat this like a DP problem. I don't know that much about DP though. Where in a strange way, what if we ran through all the zeros and ones in the array and we created a map? I'll consider these two separate approaches. Map of index to ones and zeros. If we did that, could we just write a function after that? For example, we'd know for this array, of binary strings that the top hand would look something like this: 1, 1, and 1, 0. We'd have 1, 1, and 3 zeros. Here we'd have 4 1s and 2 zeros. Why does it keep adding periods? Here we'd have, we have ones first, zeros second. So we'd have 1, 0, 1, 1, no 0. We have 0 1s and 1 0. It's a little bit confusing. Now the correct answer is 4 because the sets we want are 10, 0, 0, 1, and 1 and 0. Now it seems like what we want to do is go up to at max this number of ones and zeros, which was, what was the input? I think it was m equals 5 and n equals 3. So if we had this map, it feels like we basically want to, shove as many we want as many zeros and one. We want at most m zeros and n ones. Right? But we want to do it by maximizing the number of units we use, the number of elements we use. You can't use an element more than once. I feel like there's a few ways to do this. This map version gives me a bit of a question mark because I think the map version gives me a bit of a question mark because I think we're pretty much trying to maximize how many units it takes to reach m equals 5 and n equals 3. So what if we always just take the first unit? But surely that doesn't scale. So it can't be that simple. You could try a greedy approach. Now if we did a greedy approach, 1 0 0 0 1 0 0 0 1. I don't think that's necessarily full. What if we did do a greedy approach? What does a greedy approach look like? I feel like a greedy approach doesn't look like it has anything to do with zeros, with the length. It doesn't have anything to do with the number of ones and zeros. It has more to do with the length of the string. I feel like with a greedy approach, it's usually more obvious what your next option should be. I think this might work. What if we tried a greedy approach where we take the string with the least amount of characters next? So maybe we could flip the whole script. What if we sorted the input string, and then our greedy option will always just be our next string. And if our next string contains, a 0 that would push us over the edge, we'll skip it. So for this one, I think that would work. We take 0, 1, right? We'd be at 2. And we pretty much have no more m or n left. They didn't give us many examples, so it's hard to think of another one. An example that could fail us If we take the shortest one, we're bound to increase the cost of it. We're bound to increase the cost of it. So it's got to be possible. If we take the shortest length string, we're bound to increase the cost of it. We take the shortest one, we're bound to increase the cost of it. Or pretty much in another way, another one if this doesn't work is longest path. Opposite of shortest path. It does seem like DP, and I think DP is tied to path problems. I mean, even Dijkstra's algorithm is partially DP because it's built upon sub-solutions, optimal sub-solutions. I think this could work. Something's off though. Something's slightly off. If we sorted the whole array to be shortest by length of character, this would have to increase the size. This is at most. So they're at most. So we can have a less than that. I think this could work. Let me see if I can visualize this algorithm. So the way we want to do it is basically a greedy algorithm, except we want to be greedy on the length of the string. Length of the string has to give us the longest, not has to, maybe it's more likely to give us the longest path. So we would sort the input string. And we pretty much iterate while m and n and I, well, m and n do not equal 0. We want to stop when m and n equal 0. So if they don't equal 0, right, if we have space left, if there are still elements to choose from, and m and n aren't equal to 0, then we should keep going. So the while loop for that, what would the while loop for that even be? M is less than, actually we can just iterate over the whole array. Now that we can't do that because we want to skip certain indices. We'd like to skip certain indices. That doesn't quite make any sense. So we just do while loop over it, and then while m is less than n. I mean, while m is not m, pretty much going to be decrementing as we add characters to the subset, because we have to return a subset length. So we could have we'll sort it, have a subset, we'll return the length of the subset. We have to search through the whole list anyway. So while m and n does not equal 0, m and n does not equal 0, because you can have at most, or there's no elements left to choose from. If there's no elements left to choose from, then we'd be done. There's no elements left to choose from, then we'd be done. There's no elements left to choose from, then we're done. Oh. You know what, we'll do it that way, and then if m and n equals 0, we'll just break. But it doesn't really matter, because it'll stop anyway. Then we'll need to know, as we're iterating through, we pretty much need to know how many 1s and 0s exist within the string. We could write a function to process it ahead of time, or we could also just keep a map. We could process all the elements ahead of time, and then we could keep a map, not of index, but of actual string difference to note the number of 1s and 0s. Either way, I guess in the beginning we can just do count 0s, but it would save time to memorize it. And what we can do is, just since it's already going to be sorted by integer length, by string length, if we do the 0s and 1s minus m and n, and it's still greater than or equal to 0, then we can add it to our subset. Otherwise, we'll ignore it. So I think that's everything. So let's try that. So we'll have a subset array. We'll return subset dot length. And then before that, we need to sort strs. Have a, b, and we're going to sort it by a dot length minus b dot length. This is sort the strings based on length. Then from there, we're going to have let I equal 0 and do while I is less than subset dot length. All right, we're going to have a function, right, which is going to be, we'll have 0s and 1s, which will be returned by a function called process binary, and we'll pass it in strs sub I 0s and 1s, and we'll have while I is less than subset, right, and m does not equal 0 and n does not equal 0. What's the problem here? Oh, the line went away. And we'll say if m, which is 0s, I think, m minus 0s is greater than or equal to 0, and n minus 1s is greater than or equal to 0, I'll do subset dot push strs sub I. I'll do I plus equal 1. In the end, I think we could have just did a regular for loop over it. So maybe that doesn't matter. We'll do process binary, which will take a string. It's going to return a tuple of numbers. Let's let z equal 0 and let o equal 0. We'll return 0s and 1s in that order. We'll just iterate over the string. We'll say if strs sub I equals 0, then we'll say z plus equal 1, else o plus equal 1. I'm going to return 0 up here and just test to see if this function makes sense. So we had 2 zeros and 1 1, 1 0 and 2 1s, 0 zeros and 4 1s. And we destructure it, we take out the zeros and the 1s. Okay. Our output is 0. Now, why is that? We would have got 5 zeros. I mean, we got 1 0 and 1 1. You do n minus 1 and n minus 1, you're still greater than or equal to 0, which means you did subset dot push stir sub I. Oh, wait. No, wait. And m does not equal 0. And n does not equal... Actually, I just realized... Oh, no. They did promise it'd be at least 1. So I actually don't understand. Okay. Let me try it again. Okay. We're sorting them by A length and B length. Maybe we messed up on the sort. I don't think we did. It is indeed sorted by length. I is less than subset dot length. M, which is 5, does not equal 0, and n, which is 3, does not equal 0. So what exactly are we not? Process binary returns a string. Returns 2 numbers. Not even getting any output. Is this loop even running, bro? Oh my god, I'm using subset.length instead of stirs.length. Oh man. So it works for the first case, but not so much for the second case. Oh, I forgot to actually decrease m minus equals zeros, n minus equal ones. Even then, I looked at this array. Runtime error. Cannot read properties of undefined reading length. You know, it might just be simpler to just treat this as a regular loop. So our output was 1, their output was 3. We're looking for Wait, our output is 1 and their output is 3. Yeah, this is definitely giving me a DP vibe, right? Because we're choosing locally. I should have spent a little more time thinking through it. Locally, if we choose 3 1s, we could do better if we chose would something. It's promising that this prompt passed so many test cases, but I presume the last 14 test cases have something to do with this. Strings.length isn't very long. So we try to do it in linear time. What if we just tried brute forcing it? We'll let max subset equal to -infinity. We'll take this I out and swap this for a for loop. Actually, it's already there. Now we should have the same thing still. Now, if we add another for loop, except we'll probably want to swap M. Well, let's see. Let's think through this to see if this even makes sense. We'll take a new version for which we start at all the which will start at we'll change our starting point. Oh, maybe it's still possible for us to run into this again. It just depends on if the LeetCode people have written a test case for it. One thousand, 1,11. It also turns out we don't really need subset as an array. We can just make this equal to count, which starts at 0. Then we just return count. And instead of pushing the actual subset, we just do count plus equal 1. Set probably want this to say let. I'll run it again just to make sure we keep the same answer. Oh wait, did I forget to change something? What was max subset before? Yeah, nothing really changed. No. Ugh. I think I just had to change this to, and then add m minus equal. I think we end up with the same. We change this to a for loop. And then just return count. Is it possible? All right, and then now we just would do what we said we were going to do before. Only problem being, after we process an index, we basically not like to process it again. So we're gonna need another for loop. This one will be m. This will be the same loop as before. And then we'll have max count, which is equal to negative infinity. And then at the end of every for loop, we'll say max count is equal to the math.max of max count and count. What we'll return will be max count. And at the top of every loop, count will be equal to 0. And we'll actually need temporary variables, temp m, because they get replaced. We should have reversed this, but it's too late. And then at the top of that, we'll say m is equal to temp n, temp m, n is equal to temp n. I don't think this should change anything right now. Wait, How is this TLE? Oh my god, I'm using M as the loop here. Let me just change this to J. Okay, yeah, it should just take a little bit longer. And then at the start of every loop, count will actually be equal to 1. And we're actually going to call process Z and O equal process binary of stirs sub I. And then M is going to start out with temp N minus Z basically. This is so ghetto. I'm just going to copy this whole loop right here. I mean, this whole if statement right here. And then in here, we're basically going to skip I. J does not equal I. We should still get the same answers. So this actually breaks. And then with our output being 6. It's funny because we passed 8 more test cases. I feel like this one's probably the same as the other one. We end up with 34. Even if we change our start, that just only fixes one problem, which is just that our starting point can change. I'm pretty sure the whole thing falls apart though, because we did not assume. I think we made the assumption that the lowest, that a greedy solution would work. We'd be greediest for the shortest length solution. I mean the shortest length string. Yeah, I'm pretty sure this is a Dijkstra's problem. We want the longest path. want the longest path. Now, how does Dijkstra's algorithm work? I'm pretty sure we could do this in shortest path with n square runtime. The longest path longest path. I barely remember shortest path. Shortest path. What's the intuition behind shortest path? Dijkstra's is based on Prim's algorithm. They're so similar in that Dijkstra's algorithm changes only 3 lines, one of which is just the function name. The other 2 lines that are changed is how we evaluate the desirability of an edge. Now desirability of an edge. An edge. Another reason why I'm not exactly certain shortest paths will work is because you can have multiple starting points here. So if we had to run n, we pretty much have to get the answer, we'd have to run an n squared algorithm n times. So we'd actually end up going n cubed. That would be n cubed. And it's unclear whether or not n cubed is an acceptable runtime for this. M zeros and n ones in the subset. Shortest path. Before we go shortest path, is it possible to hammer down those last 6 remaining edge cases? Wait, what if we just always chose the next option? No, I think we just did that. No. What we did was we went greedy based on the length of the string. We thought that would lead us to the solution. Seems like that gets us 90% of the way there. What if, since it's already sorted by length, no, but that's what gave us an issue before. The greedy intuition was not flames. I guess that's the problem with the greedy algorithms. By potentially going for the instant reward, we miss out on long-term rewards. So we should last time we did the shortest path, so it was through an array and it was based on climbing stairs. Not really, it was pretty much based on a staircase problem. So you can do shortest paths on arrays. How do we know when to stop there? Just add an extra indice at the end of the array. By adding an extra indice at the end of the array, that's how we knew we had reached the end. Because we were looking from pretty much the shortest path to the end. But Dijkstra's algorithm in that tree was the shortest path spanning tree. No, it wasn't actually. It did skip elements. Dijkstra's algorithm was the shortest path. We want to do longest path. want to do longest path. What does it mean to take the longest path? What does it mean to take the shortest path? In this tree, every node is connected to another. Wait, that is true. Dijkstra's algorithm generates the shortest paths for all nodes in the tree. I'm pretty sure Dijkstra's is the way to do this. Except we want to swap shortest path for longest path. And Dijkstra's has an element of DP to it. I think this is the wave. I've been trying to figure out how Dijkstra's work, and I'm pretty sure I can't remember all the details, but if I can remember them manually, it would really reinforce the memory. But I feel like there's an intuition behind it. We're trying to evaluate the desirability of nearby vertexes, edge weighted or vertex weighted constructs. Then we have to choose, but we always load them in. When we're doing shortest path, you load them in longest first. But I'm also not exactly convinced that Dijkstra's is the way. This is mostly because when we did it before, we were just trying to get to a specific place. Here, we're not really trying to get to a specific place, although Dijkstra's does generate the shortest paths for all nearby, for all the vertices in the graph. I think the problem with this one is even if we had the shortest path, it would be the shortest path where? I think what we're low-key actually trying to do is a spanning tree. But then you don't need to visit, you don't need a tree to span the entire thing to. Or can you have an algorithm that does a variable length spanning? I didn't read enough on spanning trees to know if this is possible or not. I don't want to click related topics. I feel like it'll give away the sauce. Maybe I should click it. Oh, yeah, it's not any different than what I thought. I was already getting a DP vibe from it. So, that's fine. Yeah, whenever it seems like DP, it always also seems like Dijkstra's. I don't remember exactly how Dijkstra's works. I think I should have written it down and then compressed it into something that was more compatible with how I think. I'm trying to remember code right now. Which is the current distance. Pretty much meaning the distance between all the edges was infinity to start, and then they were revealed as we traversed through the array. The way that we traversed through the array was it was based off whichever ones weren't added to the tree already. Pretty sure the loop ran while it wasn't in the tree. While it wasn't in the tree. If it wasn't in the tree, then we did work. The work we did was evaluate the desirability of the nearby edges. Even in this problem, though, how would we evaluate the desirability of an edge? It's not immediately clear that the best way to evaluate the desirability of an edge is through the length of the string is not the way. Maybe the weight. In the ADM, we think more about designing graphs rather than graph algorithms. Maybe we could represent the edge weight. Maybe we could just deal with it as a vertex weighted graph like we did with the last one, which basically means that the weight would just be how many zeros and ones live on. Maybe the sum of the zeros and ones in the string. What we really want is the longest path between all of those. Actually, wait, if that's true, can't we just always choose? No, I think we're going in a thought loop. We already tried that. No, I think what we actually tried was basically the same thing. Can't we just look through the array on each iteration and take the one with the shortest zeros and ones? That basically correlates with the length. Do the same thing with the BFS tree. Pretty sure we just ran out of space on the heap. If you did the breadth first search tree, first time you hit the node with depth with BFS, wouldn't quite be hitting the same. BFS tree. It doesn't really matter because we run out of space on the heap anyway. Oh no, not run out of space, but we'd end up with TLE, unfortunately. I feel like we could probably something seems incomplete about Dijkstra's here. If we did longest path, we have the parent array. I'm pretty sure the way Dijkstra's work is that it's kind of stateless. I guess I'm worried that even if we did do Dijkstra's, we go through the parent array until there's no parent. That would be the path. How will they have known to stop? Well, maybe that's something we can answer after the fact. Look through all the nodes and find the longest path. Once we have all the paths, you just look through all the nodes and find the longest path that doesn't break the rule M and N. So that could work actually. So we could layer something on after Dijkstra's. Okay. Layer M and N rule after Dijkstra's through parent array. If one were to do that, then they would just be trying to make the longest path. Either way, you would have a distance array. It's just going to be an array of numbers. Then you would have you can just copy this. You would also have a parent array, which is just an array of numbers. They're not going to sort the array. And we could also do entry array of booleans. Then for let I equals 0, less than strings.length, I plus plus, do parent push -1, pretty much init all of these, distance dot push infinity entry dot push false. We'd have s, which would be our start vertex, which would pretty much be equal to 0. Start vertex should be our start vertex. S would be equal to 0. After Dijkstra's through the parent array, I'm pretty sure Dijkstra's has 2 parts. Evaluate neighboring edges. Choose next node. We'll say while entry is false, starting at this particular node, we want to evaluate our neighboring edges. The neighboring edges is the entirety of the array. So the other thing we would say, if If entry v is false, then we'll say entry is now is true because we're processing this node. Now we want to evaluate our neighboring edges. We'll just name the neighboring edges W. We'll say W is less than stirs.length W plus plus and the nodes cannot be the same. V cannot be equal to W. These are our neighboring nodes. What is the distance array again? The distance array is the amount it took to get to where you are. So another way, maybe we have to say that distance sub v, probably do need the, actually we can just use the weight. You can just use the length of the string sub v dot length. I want to evaluate the neighboring edges. I want to choose the next node. Evaluate the neighboring edges, then choose the next node. I feel like if we looked at Dijkstra's, we could solve this right now. Then we always have to look at Dijkstra's. I'd like to be fair, the first time we used Dijkstra's, it took us 3 days. So I'm sure if we looked at it this time, it would take much less time. This time I'll take extra time to compress it. But I think we're going to stop there for now, even though I think I could go longer, but probably a good place to stop. We'll be back tomorrow.